Okay, so let's talk about the general logarithmic function. Okay, so if a is not equal to 1, then we see that logarithmic functions, exponential functions are 1 to 1, which means that there's an inverse function. And so we can write y as a log base a of x. This is the general log function. So where we have a natural log, the natural log has a base of e. Okay, we're going to now generalize it to all log functions, okay, including those with base e. So now, this is, if we have a log function, then if it's 1 to 1, then we know that this is true if and only if we have this. Right, so this is going to be x equals a to the y, right? So these are equivalent, right? So we can take any logarithmic function and write it in exponential form, okay? These are representing the same curve. So now we can change any log to a natural log, right? So we can represent any log as a natural log. And to see this, let's take the natural log of both sides here. So we get the natural log of x equals the natural log of a to the y. And of course, using the properties of logs, we get natural log of x equals y times the natural log of a. And if we divide both sides, we get, by this, we get y equals the natural log of x over the natural log of a. Okay. And so what do we have? We show that log a of x is equal to the natural log of x over the natural log of a. And in other words, this is where we get the change of base formula, by the way. Notice that this is using the change of base formula. We just derived the change of base formula. Okay? In a manner of speaking. So, what does this show? Well, what this shows is that every function is a constant multiple of another, or log functions. So all log functions are basically a constant multiple of each other. This is just a constant, right? This natural log of a is just a constant, so these are just multiples of each other. So that means we can use a formula to differentiate, find a differentiation formula for a logarithm with a base a. Okay? So we're going to use this formula, right, to find the differentiation formula. So that's what's coming next. So now what are we going to do? Let's do it. So if we differentiate this, let's just leave this here where it is, right? So if I want to differentiate this, I can differentiate both sides. So if I want to find the differentiation in the general case, right, then I can take the differentiation of this side, right? And the bottom number is just a constant. So I can pull that out. So I can pull this out. So let's pull it out. So this is equal to, this is 1 over the natural log of a, right? And then I get the derivative with respect to x of the natural log of x, which we know what that is. That's just 1 over x. And so guess what? We get 1 over the natural log of a times 1 over x, which gives us 1 over x times the natural log of a. And that's our differentiation formula for logs. So now, that brings us to our next theorem. See you next time.